Good morning, everyone. Today we would like to present our group inspection and assessment report for the course IHS 248. Our inspection was conducted at Mitsuboshi Chemical SDN BHD, where we assessed the local exhaust ventilation system. This project was carried out by our team, myself, Alia binti Ahmad Musfi, Ahmad Fakirin Haikal, together with Danish Farizi and Syed Muhammad Izzat and also Muhammad Afif Danish. Let's begin with the executive summary of our findings. So let's begin with the executive summary. This section gives a brief overview of the inspection and testing conducted on the local exhaust ventilation or LEV system. So, this report described the inspection and testing of the local exhaust ventilation (LEV) system at Mitsuboshi Chemical SDN BHD, conducted on 22 April 2025. The main purpose was to check if the fume hood in the laboratory is working effectively and safely based on the requirement of the Usage Regulation 2000 and the Factories and Machinery Regulation 1970. Several instruments were used to measure airflow, pressure, and fan performance. The phase velocity was found to be 83 feet per minute, which is within the safe range, and the airflow inside the duct also met recommended values. This result shows that LEV system can still control and remove chemical fumes properly. However, some minor issues were noted, such as dust on the filters and wide sash opening during use, which can reduce the system effectiveness. Overall, the system is in a good condition and provides proper protection for workers, but regular maintenance and improved work practice are needed to ensure it continues to perform well.
Let's start with introduction. Date of assessment 22 April 2025. Location Mitsubishi Chemical Sdn Berhad Creative Biopolymer Park Terengganu. Okay, for the purpose, evaluate effectiveness of LEV system in controlling airborne contaminant in the laboratory. Okay, for the compliance, assessment aligned with use regulation 2000 and Factories and Machinery Safety, Health and Welfare Regulation 1970. Okay, next objective. First, to assess the operational performance of the local exhaust ventilation or LEV system. Second, to evaluate the system capability in capturing and controlling airborne chemical contaminant. Third, to ensure the LEV system complies with national occupational safety regulation, including use 2000 and FMA 1970. Okay, last one, to support continuous improvement in laboratory safety and engineering control effectiveness. And this is one for the detail of the system.
For my part, I will explain the methodology used to evaluate the performance of the local house ventilation at Mitsuboshi Chemical Berhad. The first procedure is we need to list of equipment used. The performance of the local house ventilation and general ventilation system are evaluated based on the data gathered from the on-site measurement within house ventilation system. Figure 1 shows the list of equipment used in this examination. The second procedure is system inspection. Number 1 is observation around the hood were made with respect to the following factor like physical condition of the hood, type of hood, and the condition of the wood area. A small test was conducted 1D from the hood face. D is the diameter of the duct. Hood velocity measurement were taken to measure the capture velocity using a rotating vane anemometer. Third and fourth procedure is a ducting testing measurement and motor or fan. For the ducting testing, observations along the ducting system were made with respect to the following factors, such as the physical condition and necessary rules along a ducting system, and the third one is the location of damper. For the motor or fan, the fan speed RPM and motor speed RPM were measured using a tachometer. For the fan static pressure and the exhaust flow rate were determined by measuring the following parameter. 1. Inlet and outlet static pressure. And 2 is inlet velocity pressure. Last one, I will talk about standard and guideline for LEV. Phase velocity for hood, vertical/airflow hood for full open area depending on the quality of supply air distribution and uniformity of phase velocity. Like the picture is the example for vertical/airflow hood, and the second picture is natural of contaminant.
Okay, next I'm gonna continue with results and calculations. The first part of the results involved phase velocity measurements at the fume hood. We tested both the current and baseline conditions with the sash fully open at 1.97 feet. As you can see, the phase velocity under current condition is slightly lower than baseline, but it is still within the recommended range of 80 to 100 fpm. This means the containment performance remains acceptable, though slightly reduced. Next, we measured the transport velocity, static pressure, and total pressure at 4 test points, PT1 to PT4, along the duct system. All duct sections had the same diameter of 8 inches, giving a duct area of 0.349 feet. We calculated values using these formulas. As you can observe, all test values are within the recommended velocity range of 1000 to 2000 fpm, and the flow rates remain consistent across the duct system. Overall, the ventilation system is still functioning effectively. Although the current values are slightly lower than the baseline, this may reflect reduced fan speed or improve energy efficiency. The airflow is stable, pressure values are reasonable, and the transport velocity supports sufficient contaminant capture.
Next, I will talk about discussion of the result. First, fume hood phase velocity. 83 fpm within a CGIH recommended range 80 to 100 fpm indicates good chemical fume capture performance, slightly lower than baseline value 89 fpm. So for duct transport velocity, range between 1699 to 1835 fpm at all test points, within recommended range 1000 to 2000 fpm. Minor drop in static pressure and velocity possible due to fine dusty buildup or small leaks. So for general observation, the tested LEV system was a standard lab fume hood with an 8-inch duct. The physical condition was good with no unusual noise or vibration. Airflow was slightly reduced, likely due to dust on the filter. Tough, no visible duct leaks were found. Next is work practice. Lab users closed the sash when not in use but left it to open during experiments. Reducing fume capture, chemicals were placed too close to the hood edge, risking contamination, and users keep visual airflow checks before starting work. Next is recommendation. First, system improvement. Regularly service exhaust fans and clean filters to ensure optimal airflow. Second, add an airflow monitor with a digital indicator to the fume hood so users can see if the phase velocity is still within a safe range. Lastly, double check ducting for any subtle leaks that may reduce system performance. Next, work practice improvement. Retrain laboratory users to keep such openings to a minimum during experiment to improve fume capture efficiency. Ensure that all chemicals are placed at least 15 cm from the edge of the hood while working. Lastly is regulation, compliance and others. Ensure that the LEV system continues to comply with the use regulation 2000 and the factories and machinery safety health and welfare regulation 1970 by carrying out annual tests and keep record of inspection and maintenance for those audits.
For conclusion, based on the inspection and testing conducted at Mitsuboshi Chemical Berhad, it can be concluded that the local exhaust ventilation (LEV) and general ventilation (GV) system are functioning effectively. All major phase velocity and the duct transport velocity value were within the recommended range set by ACGIS standard. No major issues were found in the system performance and the equipment was in a good working condition. Therefore, the objective of this assessment was successfully achieved. However, it is recommended that the company continue to perform regular maintenance and monitoring to ensure long-term system efficiency compliance.
Lastly, these are our references.